Dr. Evseenko from University of Southern California contacted us to incorporate mechanical testing into one of his studies. How does medial meniscal tear affect the joint in a rat model? Therefore, a medial meniscal tear surgery was performed on a rat model to induce osteoarthritis. A major challenge in characterizing the outcome of this degenerative model is related to the very small size of the samples. In order to demonstrate the performance and sensitivity of our mechanical mapping technique in detecting potential osteochondral changes a few weeks following surgery, our scientists, in collaboration with Dr. Evseenko's lab, designed a short pilot study. 2 closed knee joints from the same rat were shipped overnight to our facility. Upon arrival, we carefully extracted the tibial plateau, distal femur, and patella from each joint by ensuring that all ligaments and excess tissue were removed. Each articular surface was then glued onto a sample holder. The sample holder was then screwed into a testing chamber, and the assembly was fixed onto the tester's horizontal stage. A camera registration system called the mapping Toolbox was used to obtain a top-view image of the sample. Then, a position grid was superimposed on the top-view image to define measurement positions. We used our multi-axial mechanical tester equipped with a 17 Newton multi-axial load cell, a spherical indenter of 0.5 mm diameter, and a 26 gauge needle probe. The articular surface is in the testing chamber and is submerged in phosphate buffer saline solution. The spherical indenter is lowered until the indenter's surface is positioned at about 2 mm over the highest point of the sample surface. The Mach-1 motion software displays the vertical and horizontal stages positions. It also displays signals from the multi-axial load cell, which are the forces and torques in all 3 directions. A representative example of the automated indentation and thickness technique will be shown on the femoral condyles. The first step in the automated indentation technique is to measure the contact coordinates of the predefined location. Step 2 consists on measuring the contact coordinates of surrounding positions. Then, the surface orientation is calculated using the measured coordinates. Based on the surface orientation, the multi-axial mechanical tester uses the 3 displacement components to provide a perpendicular displacement. So a normal indentation is performed at the predefined position. The normal indentation curve is saved in a text file. The outputs of the automated indentation technique are the surface orientation and the normal force in function of time and displacement. However, the thickness is missing for further analysis of the curve. By replacing the indenter with a needle probe, thickness measurements can be performed. The needle probe is vertically displaced towards the sample at a predefined speed. There is a small load increase as the needle reaches the articular surface, and a sharp load increase as it reaches the subchondral bone. The needle penetration curve is saved in a text file. The outputs of the automated thickness technique are the force in function of time and displacement, where the position of the cartilage surface and the subchondral bone can be obtained. Using the normal stress relaxation curve obtained by normal spherical indentation and the load versus displacement curve obtained by needle penetration, analyses were performed to calculate the instantaneous modulus and the cartilage thickness at each position of the mapping. A software was used to generate mappings of the instantaneous modulus and the cartilage thickness for each articular surface. These high-resolution mappings were created using around 80 positions per surface. Now let's take a look at the femoral condyles. A thinner cartilage region can be observed on the medial femoral condyle of the treated knee. Along, a stiffer region suggesting bone exposure is surrounded by abnormally softer cartilage in the medial femoral condyle of the treated knee compared to the untreated knee. Now the tibial plateau. A thinner cartilage region was also identified on the medial tibial plateau of the treated knee. As can be observed on the femoral condyle, a stiffer region surrounded by abnormally soft cartilage was observed in the medial tibial plateau of the treated knee. Mappings of the tested patellas also revealed a drastic decrease of cartilage stiffness of the treated knee compared to the untreated knee. These results demonstrated the potential of our techniques in understanding the functional impairment in knee joints following MMT surgery. This study was completed within 2 days. For more information, please contact us through our email address or website.